Hey, it's Paul. Let's continue from our rectangle example and looked at the tapped event. So inside of our rectangle here, you could add a tapped, and that means whenever we tap this rectangle, we can do a particular event. Now, if you remember, this event down at the bottom here was while pressed. So while pressed, if we click the rectangle, it changes the color and of course rotates this 180 degrees. Could do something different while we tap it though, so it could have a different animation if we tap the rectangle. So this one is held down. If we simply tap it, it could be something different. So maybe we want to do something like a move. And with the move, we could change the X and Y. So if we add a Y, and for now I'll add 100 and an X of 50, and a duration of perhaps half a second. So it takes half a second for the rectangle to move. And we simply just click or tap the rectangle. We can see that it starts to move. But for now, I'll also comment out this while pressed so we can see this in its entirety. So if we click the rectangle, we see it moves down by 100Y and 50X. When dealing with animations, we also have something called an easing. And this is how we want the animation to move over a curve. For example, we have things like bounce in, bounce out, circular in, and so on. If we take one of these, for example, and said easing, equal to exponential in out, and we tap our rectangle, you can see that it sort of takes a different path than before. If we use something like bounce in, and we tap, you can see it takes an entirely different path. If we use something like quartic in out, you can see that it also takes a different path. So there's different easing values that we can use. We don't necessarily have to stop at movement though, we could also use scale. So scale allows us to change the width and height of our rectangle by a particular factor. So if we changed it by a factor of 3, we would think that our rectangle would get significantly bigger. And if we click our rectangle, we of course see a much bigger rectangle, but perhaps that's too quick. So let's say we have a duration of instead 0.5. And if we save the file, you can see that it also gets bigger at a smaller rate. We can change this to be 100 for X and Y, and maybe put the duration to be something like 2. And if we change the factor of our scale to be a little bit smaller, maybe you could find use for that animation somewhere. I'm not exactly sure where, but there we have it. We've looked at movement and scale within our Fuse applications. I should also add that the scale here is obviously the base scale factor of 1, so we'd have to change that to 2, or anything higher or below the scaling factor. So we could say 0.5, and this would make it smaller. But I know what you're thinking. We have this thing here. What if we wanted to move this again, but maybe we wanted to change the movement to instead be delayed by maybe a second, and then the X would go to 200. We'll add that to be a duration of 1, this to be a duration of 2. So this is delayed 1 second, and then our other movement starts. Let's take a look at that. So if we save the file and run the animation, we see that it gets smaller, it moves again off screen after that second, comes back to the initial moved place, and then finally goes back to the initial scale and the initial starting point. If we change this to be 200, 100, we would see our box, so we could do this again. So we can see it throughout all of the movement. So we do actually have quite a powerful animation system in Fuse, and if you'd like to see more Fuse videos, then of course hit that subscribe button. Let me know what you'd like to see in the comment section below, and until then, I'll see you very soon in the next video.